students. I just want to introduce myself. First of all, I'm Dr. Davis. I am your instructor for this course, and I want to take the next 30 minutes or so just to give you an introduction of what to look for in Unit 1. The first things first, of course, is the number line as you see on this piece of paper. And you notice by the way I have it labeled between -3 and 3, I have small bars that represent where each number is. So if I were to tell you, go and find where is 1 on the number line, of course you would fill in a little circle right here. If I were to ask you, where is -4 on the number line? Well, even though -4 is not listed, it's actually right here, and it's on this side. You can actually look at the number line in terms of less than and greater than. For example, if I were to tell you 1 is greater than 4, would you agree? Is 1 greater than 4? If 4 is technically about here, if I tell you 1 is greater than 4, is that true? Well, 1 is closer to 0, 4 is further from 0. So that means 4 is actually greater than 1. So this 1 is greater than 4 is actually false. For example, is -2 less than 1? Well, here's -2. -2 is furthest away from 0, and 1 is very close to 0. But -2 is indeed less than 1. So, let's look at one more. 10. Is 10 less than -19? Ask yourself, based on what you know about whole numbers and negative numbers and positive numbers, is 10 actually less than -19? Well, -19 is way out here somewhere, and 10 is way out here somewhere. So is 10 less than -19? No. So this would be false. Okay? Now, let's move on. Let's talk about adding and subtracting integers. Adding and subtracting integers. First of all, integers are whole numbers. So, let's look at some problems and see what we know based on positive and negative numbers. For example, 2 plus -2. Of course, we have two different operations going on. So 2 plus -2, if you were to look at it, you could actually say 2 minus 2. And that is the equivalent of what is 2 minus itself, which is 2. 2 minus 2 is 0. How about 3 minus 1? What is 3 minus 1? You can also use a number line. If you're at 3, if I move back to the left one place, 3 minus 1 is actually 2. 4 minus a -2. Think about what we know about signs. 2 negatives make a what? 2 negatives should make a positive. So this is the equivalent of 4 plus 2. What is 4 plus 2? If you're at 4 on the number line, if you go 2 places to the right, 1 place and another place, you end up at what? You should end up at 6. Okay? Let's try a few more. What is 8 minus 7? If you're at 8 on the number line, you go to the left, 7. What is 8 minus 7? It should be 1. Okay? Let's do one more. 3 minus a positive 2. This is the equivalent of 3 minus 2. Because, of course, that negative sign is distributed inside of that parentheses. So 3 minus 2 is what? 3 minus 2 should be 1. Okay? Now, let's talk about adding and subtracting fractions. so good. All right, adding and subtracting fractions. The way I will be writing them is left to right form, but it's the same thing. 1/2 plus 1/2. 1/2 plus 1/2. So you have one whole orange. You cut it in half, so now you have 2 halves. If you put the 2 halves on top of each other, what do you now have? 1/2 plus 1/2 is what? It should equal 1 whole. Okay? What about 1/3 plus 4/3? When the denominator is the same, we just add the numerators and go from there. So in this case, our denominator is 3. It's the same in both instances, so we just add the numerators. 1 plus 4 is just 5. And then, of course, the denominator is just 3. How about 2/6 plus 2/6? Same denominator, so that means we can add the numerators. 2 plus 2 is just 4/6. But 4/6 can be reduced or simplified if you look at it that way. What number can be divided into both 4 and 6, therefore simplifying the fraction? If you look at 4 and 6, if you look at the factors of 4 and 6, the factors of 4 is 1, 2, and 4. 1, 2, and 4. The factors of 6 is 1, 2, 3, and 6. What factor has been repeated? That would be 2. So we can say divided by 2/2. 4 divided by 2 is just 2. 6 divided by 2 is just 3. That is the reduced version of 4/6. Okay, let's keep going. 3/7 plus 1/7. Same denominator. Just add your numerators. So now you have 4/7. Okay, let's do some more. How about 1/10 plus 4/10? Take a moment to write that out on the sheet of paper. 1/10 plus 4/10. What does that equal? What does that equal? 1/10 plus 4/10. This is the equivalent of same denominator, which is 10. Add your numerator. 1 plus 4 is 5/10. 5/10. What can you do to reduce or simplify this? You can divide by what? Divide by 5/5. 5 divided by 5 is just 1. 10 divided by 5 is just 2. All right. Let's keep going. Now this is, of course, adding and subtracting fractions is basically for this particular equation, is basically for situations where the denominator is the same. In the event that the denominator is not the same, we need to find ways to find the common denominator. Let's try 1/2 plus 1/3. Factors of 2 are 1 and 2. But if you were to look at it in terms of multiples of 2, that would be a little bit easier. Multiples of 2 are 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. So on and so forth. And then multiples of 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So on and so forth. What is the common denominator in this case? Look at, there's a 6 here and there's a 6 here. Or the equivalent of 2 times 3 is just 6. Okay? So what we would have is 1/2 plus 1/3 equals, since our common denominator is 6, how many times does 2 go into 6? 2 times 3 is 6. So 1 times 3 is 3. So we have 3 over 6. Going back, 2 times 3 is 6. 1 times 3 is 3. Okay? Plus, we'll have a 6 in our denominator for the 1/3. So 3 goes into 6 how many times? 2. 1 times 2 is 2. So we have 2 over 6. Just to recap, 3 goes into 6 2 times. 1 times 2 is just 2. So 3 6 plus 2 6. 3 plus 2 is 5 over 6. Okay? Alright, let's keep going. Multiplying and dividing fractions. Multiplying and dividing fractions. Alright. What does it mean to multiply and divide fractions? Well, first of all, it's similar to what we did in addition, except it's a different operator in the middle. It's a multiplication in the middle. So, for example, 1/2, I'll use the word times 1/3. Now we're multiplying numerator by numerator, and then denominator by denominator. So 1 times 1 is just 1. 2 times 3 is just 6. That's it. That's all you have to do. Let's keep going. 1 4 times 2 6. Same concept. Multiply the numerator and then multiply the denominator. 1 times 2 is 2. 4 times 6 is 24. And what can reduce 2 over 24? If you divide by 2 over 2. 2 divided by 2 is just 1. 24 divided by 2 is just 12. Okay? Let's keep going. How about 3/4 times 3/8? What is 3 times 3? 3 times 3 is just 9. 4 times 8 is just 32. How about we do the number 1 times 1/2? 1 is the equivalent of 1 over 1. So 1 over 1 times 1/2 should be just 1/2. Okay? 6/7 times 3/4 equals. What's 6 times 3? 18. What's 7 times 4? 28. Now, 18 over 28, can that be reduced? Yes or no? And if so, by what? I'm thinking divide by 2 over 2. 18 divided by 2 is just 9. 28 divided by 2 is 14. Okay, so that's multiplication. Now, let's do a similar thing, except now we're dividing. So, let's go back to the initial equation. 1/2, instead of times 1/3, let's say divided by 1/3. In this instance, we're going to flip the second fraction so that the numerator becomes the denominator becomes the numerator. So now it looks like 1/2, and when we do the division, when we do the flip of the second fraction, we now make the operator in the middle multiplication. So we go from division, 1/2 divided by 1/3. When we rewrite the sentence, it's still 1/2. We change the operation in the middle to time, and we flip the second fraction. So now we have 3 over 1. So 1/2 times 3 over 1. What is 1 times 3? 3. What is 2 times 1? 2. Okay. 1/4 divided by 2, 6. Bring down 1/4. Change the sign in the middle. Flip the second fraction. 1/4 times 6 over 2. 1 times 6 is 6. 4 times 2 is 8. 6 divided by 8, if you divide by 2 over 2, you get 3 over 4 in reduction 4. Okay? Now, let's do 24 divided by 4 over 1. Same concept. Bring over 24. Multiplication sign in the middle. Instead of 4 over 1, we now have 1/4. So what is 24 times 1? Of course, 24. And since 24 is actually 24 over 1, what is 1 times 4? 4. 24 divided by 4 is the equivalent of the whole number 6. Okay? All right. Now, let's talk about absolute value. Absolute value is the instance where a positive number remains positive and a negative number becomes positive. Okay? Here's an example. We have -6 inside of the absolute value, and the absolute value basically kicks any negative sign out of the sequence. So the absolute value of -6 is actually just 6. The absolute value of -10, again, same concept. The absolute value kicks the negative out and makes it a positive 10. Now, what if we started with a positive number? What happens to it? It remains positive. Same thing with the absolute value of 1. It will always be just 1. The only difference is, what if there's a negative sign outside of the absolute value of -1? Is the number going to be positive or negative? Well, first of all, the absolute value of -1, as we mentioned, a negative number becomes positive. So the absolute value of -1 is just 1, but this negative on the outside makes it a -1. Okay? Let's do the same thing, but this time with a positive number. Absolute value of 4 is just itself 4. But that negative outside makes it -4. Okay? Questions. I know we've gone through a lot of concepts so far, but I want to try to do these videos every week for you all, so that way you can get the hang of the material that you'll be covering. Now, let's talk about evaluate. Evaluate. Alright, say I give you a number such as 4 squared. 4 squared is the equivalent of 4 times 4. Well, the question is, what is 4 times 4? 4 times 4 is just 16. Okay, what if I did the same thing, but this time 2 to the third power? All you do is expand it to say 2 times 2 times 2. Well, first of all, 2 times 2 is just 4. What is 4 times 2? 4 times 2 is just 8. Let's keep going. 5 to the third power is 5 times 5 times 5. What is 5 times 5? 5 times 5 is 25. 25 times 5 is the equivalent of 125. Okay? 6 to the second power is the equivalent of 6 times 6. What's 6 times 6? 36. Okay, let's do one more. 3 to the fourth power. 3 to the fourth power is the same as 3 times 3 times 3 times 3. What is 3 times 3? 3 times 3 is 9. And another 3 times 3 is 9. What is 9 times 9? 81. 9 times 9 is 81. Okay? Now, let's talk about putting numbers from least to greatest. Putting numbers from least to greatest. Alright, say I have -6, 7, 3, -14, and 0. How would I order these from least to greatest? When they say least to greatest, they mean from negative to, of course, 0 to now the positives. So the highest negative that we have is negative 14. The next highest negative that we have is negative 6. Well, 7 and 3 are positive numbers, but we still got a 0 there. So 0 goes next. And then, from there, 3 is the closest to 0, and 7 is closest to 3. This is how you would range least to greatest. Okay? And we'll just go ahead and mark it here as answer. Okay, let's do another one. 10, 15, 20, negative 2, negative 9, negative 100. Now, how would this be answered? How would this be answered? Again, we start from our highest negative, come all the way down to 0, if 0 is mentioned in our sequence, and then go all the way out to the positive numbers. So, let's do, our highest negative is negative 100. Our next highest is negative 9. Our next highest is negative 2. After that, of course, if 0 were mentioned, it would be right here. But 0 is not mentioned. So now we go to what is closest to 0, 10, then 15, and then 20. All right, questions up to this point on least to greatest. I know it's a lot of information at one time. Feel free to pause and then come back, because I know it's a lot of information, but I just want to make sure that I have this video done for you all so that it will be a great help for you as you submit your assignments. All right, let's keep going. Let's do order of operations. Order of operations is PEMDAS. P is parentheses. Exponent is x to some n exponent. Multiplication is times. Division is the divide sign. Addition is plus. And of course, subtraction is negative. Okay, let's go through it one more time. Parentheses, exponents. Multiplication, division, addition, subtraction. All right, let's do some problems. 7 times 10 plus 3. Well, the first things first, what do we do first in PEMDAS? Do we do multiplication first, or do we do what's in the parentheses first? We should be doing what's in the parentheses first. So in the parentheses, 10 plus 3 is actually 13. So this is the equivalent of 7 times 13. What is 7 times 13? Well, give me just 1 second. Let me find my mouse. 7 times 13 is 91. All right. Now, let's try another one. 8 minus 3 times 6 plus 2 equals. 8 minus 3 times 6 plus 2. What do we do first? Parentheses or subtraction? We're supposed to do parentheses first. What is 6 plus 2? 6 plus 2 should be 6, 7, 8. So now we have 8 minus 3 times 8. 3 times 8 is just 24. What is 8 minus 24? 8 minus 24 is negative 16. And you can keep your negative close to it, or you can move it a little farther away if you like. Okay? Let's do another one. 4 times 8 minus 6. Which goes first, multiplication or subtraction, according to PEMDAS? Multiplication goes first. 4 times 8 is just 32 minus 6. Last operation left is subtraction. 32 minus 6 is just 26. Okay? Next, 6 divided by 3 plus 3 plus 6. So the question is, which parenthesis do you do first? Well, first of all, once you get parentheses, now you look into the parentheses to see which operation is listed. In the first set of parentheses, it's division. In the second set, it's addition. So now we have we do multiplication first before addition. So 6 divided by 3 is just 2. 3 plus 6 is just 9. 2 plus 9 is just 11. Okay? Alright, let's keep going. 8 times 9 divided by 1 times 2. Well, in a parenthesis, you have an operation, 9 divided by 1. What is 9 divided by 1? 9 divided by 1 is just itself. So 8 times 9 times 2. So what is 72 times 2? That is the equivalent of 144. Alright. 19 minus 10 divided by 2. 10 divided by 2 is, of course, inside of the parentheses, so we do that first. 10 divided by 2 is 5, so 19 minus 5 is 14. Alright, so just a basic recap of what we've done so far. We've done the number line, we've done adding and subtracting integers, we've done adding and subtracting fractions, we've done multiplying and dividing fractions, we've also done absolute value. We did the evaluation as it relates to numbers with exponents, and we've also done simplifying through the order of operations and deciding least to greatest. Okay? We got about 3.5 minutes left, so I just want to do a few more problems with you. This time, some word problems. If I have $15 and 2 cousins, and we want to go to the movies. If the movie cost $4 and popcorn cost $4, can we get a ticket and popcorn to share? First of all, there are 3 people going to the movies. Remember, I only have $15, and it's me and my 2 cousins. So if the movie costs $4 for 3 people to go, well, first of all, how much is that? What's 4 times 3? 4 times 3 in this case is $12. Going back to the beginning, I only have $15. But popcorn costs $4. If I started out with 15, I've just given away 12. What's 15 minus 12 for the movie admission? That's just $3. If popcorn costs $4, we don't have enough. So no, we cannot get popcorn. But we can afford movie tickets. Okay? Last problem. I have $20 and I want to get a shirt that is $15. Plus 6% tax. Can I afford the shirt? Well, first of all, I have $20, but the shirt is $15 and 16% tax would take me to, let's pull up the calculator real quick, if it'll come on. I guess I'll have to bring it up on my phone. 15 times 0.06 is 0.9. 0.9, which is 15 I do have enough.